Again, so this is video 10, queuing management. We must make a decision to avoid this situation. We are losing clients, we're losing sales, we're losing clients. This is bad for our reputation. And well, the decision that we make is to hire an additional worker. All right? We analyzed the process that this worker is doing. We saw that he's very efficient. It's not a problem with the worker. The problem is that we have many clients and we need another worker in there. Okay? So now, as we hire another worker, S will be 2. And now we have a change in the model. Okay? So now it's model 3 because we have more than one worker. Okay? We have more than one worker. This will be 1.2, the same. Remember, when it's model 3, we never, what we never do is to multiply this by 2. We don't do it because later when we will use the LQ table, this is already included. When we go to the second column or the third column, this is the number of servers, so we don't need to do this before because we will do it later with the LQ table, but the LQ table has the result of this once it's done. So never multiply this by 2 or by 3 or by 4, no? Never. Okay? We do this in process analysis, but not in here. All right, so now we can say that there is not necessarily a perpetual queue. We still don't know, but let's say that probably there is no perpetual queue. It could be a perpetual queue, okay? But now we will check the LQ table and we'll see if there is a perpetual queue or not. If we go to the LQ table, we look for the second column because the number of channels is 2. And we look for this figure 1.2. If we see this sign, then this will mean perpetual queue. But if we see a figure, a number, this will mean that there is no perpetual queue. Okay, so let's go to the LQ table. We must look for 1.2, second column, 1.2. Okay, 1. Okay, second column is in here. Now I'll make it bigger. Where is it? 1.2, column 1, column 2, 06750. 06750. See it? Zero 6750. So this will be LQ. 0 wrong 6 7 5 0. Okay, so we have enough. So by now we know that there is no perpetual queue because this is not infinite. Right? So now we can work out. This is the number of clients queuing. Okay, number of clients queuing as an average, right? And now we can work out how long for are these clients queuing. We can work out the number of clients in the system and how long they are in the system. And later we'll do some of the little things. All right. So remember that WQ is LQ divided by lambda. So in this case, this is 0.56750 divided by lambda, that is 3. You can do it at home, okay? And then we check the result, okay? Try it, so you practice. That's 0.225. This is 0.225. 0.225 what? We are dealing with clients per hour, no? So this is hours, and this doesn't say so much, no? How much is it? 0.225 hours. I don't know. Let's multiply this by 60 minutes hour. Multiply by 60. And this is 13.50 minutes. Okay? Hours go away with hours, so we have minutes. And this is the same as 13 minutes, 30 seconds. Okay? Half a minute is 30 seconds. So now, if you go there, you will see between 0 and 1 people queuing, okay? More often 1 than 0. And these people will be queuing for an average of 13.5 minutes, 30 minutes, 30 seconds. Well, we don't like to queue, but this is better than the previous situation in which we had a perpetual queue. At least now you know, as an average, how long you will have to queue. All right? Now we'll go for LS. We need the equation for LS. Can you look at your formula sheet, because I don't have the equations in here. LS is LQ plus lambda mu. All right? So this will be LQ, that is this. Put this to the right. LS 0.6750 plus, we have this is this 1.2. All right? So this will be 18750 clients in the system. Okay, this is what it means. So we will have 1.8750 clients in the system as an average, so between 1 and 2, more often 2 than 1. And how long will these clients be queuing? So we get LS divided by lambda, and this equation is the same for the three models. And we get that this is 1.8750 divided by lambda, that is 3. And this will give us you can do it, eh? Do it. 0.625 hours. This doesn't say so much. This is correct, but it doesn't say so much. We multiply this by 60 minutes 1 hour, and this will be 37 minutes and 30 seconds. I don't know if this is. You can see it, yes. 37 minutes and 30 seconds. There is something more that we can do now, and this something more is, let's check that this is correct. Okay? We have a way, we have a little tip to check if this is correct. This is the time during which a client is in the system. In this, the time during which a client is queuing. So the difference between the time that you are in the system and the time you are queuing is the time during which you are being served. All right? So the difference between this time and this time must be the service time. Right? What is the difference between 37 minutes 30 seconds and 13 minutes 30 seconds? Which is the difference between one and the other? 37 minus 13, 24. Is this the service time? Oh yeah, is this. Okay? One client, service rate. One client every 24 minutes. So if you work out this difference and you get this result, probably you are right. If you get a different result, for sure you are wrong. Okay? When it's the same, probably you're right. Maybe it's the same for a coincidence and then you're not right. But usually you get this, it means that you are right. And now we are asked about something else, that is, as customers were really unhappy with the previous situation, they know something about this new configuration. Oh, I heard that in the big warehouse they have a new worker. They have 2 workers now, so there is not this horrible queue. You have to queue for just some minutes, but it's not as it used to be. But then, which is the probability of waiting if you go there? Okay, this is quite interesting. I want to know, before I go there, which is the probability of waiting, because I don't like, remember that in this chapter, we don't respect this distinction between queuing and waiting, okay, that we did in process analysis. So which is the probability of waiting? We use this equation for model 3. This is S. Lambda minus 1. Okay, so the probability of waiting will be 0, 6, 7, 5. We don't need the 0. Okay. S is 2, the number of channels, multiplied by mu. Mu is 2.5, divided by 3, that is lambda. Okay, and we subtract 1 from all this. Okay, and the calculator will be better than the smartphone. No, it's a pen. Okay. We're here. So we multiply by 2.5, divided by 3, minus 1, multiply by 0.675. 0.145. So 45% of probabilities that you will have to wait, you will have to queue. If you go there, it's quite a high probability, but chances are that you don't have to wait. If you have to wait, you know that the average waiting time or queuing time will be, we have in here, 13 minutes and 30 seconds. So it's not horrible, all right? But you have the chance of not waiting, that it will be the complement of this, 55%. So if you're lucky, you won't have to queue. So now the situation is much better. It's much better than before. People talk about it, people know about it, and now what happens is that this business becomes more successful in terms of clients. Let's see what happens because of that in the following video.